Okay, let's look at another example in 8.5. Let's just look at 31. This problem is based on information taken from Life in America's 50 States. A sample of 153 people ages 16 to 19 was taken from the island of Oahu, Hawaii, and 12 were found to be high school dropouts. Another random sample of 128 people ages 16 to 19 was taken from Sweetwater County, Wyoming, and 7 were found to be high school dropouts. Do these data indicate that the population proportion of high school dropouts on Oahu is different either way from that of Sweetwater County? Use a 1% level of significance. Okay, so when we set up our problem, this is number 31. Okay, let's go ahead and write the information we're given. We have the sample from Oahu, in which we had a sample size of 153 people. And it told us here that 12 were found to be dropouts. So that's going to be my X1. Sometimes they call this R1. Okay. Then I have my sample from Wyoming. And we had 128 people. And the number of high school dropouts there between the ages of 16 and 19 was 7. So we want to know, when we do our 5 steps here, we have the null hypothesis and the alternative hypothesis. So remember, the null hypothesis is always assumed to be that the two population proportions are equal. We know we're dealing with population proportions here because the problem's question, all you have to do is read it. Do these data indicate that the population proportion? So right when you see that, you're dealing with p's, not mu's, okay? The null is always where it's assumed to be true. The alternative is what we're testing. This question asks us, do these data indicate that the population proportion of high school dropouts on Oahu is different? Either way. So we don't want less than or greater than, we want not equal to, right? So is this right-tailed, left-tailed, or two-tailed? This is a two-tailed test. Correct? Okay. So if we were asking if one was larger than the other, you want to look up here. If Wyoming was larger, it would be less than. If you're testing Oahu's larger, it would be greater than. And that can help you determine this alternative when you're dealing with right-tailed and left-tailed tests. Okay, step 2 is let's go ahead and do our test statistic. So we're going to go on our calculator, go to Stat, Test. Since we're dealing with proportions and we have 2 of them, we're going to go down to number 6, 2 prop Z test. So our X1 for our first sample was 12, N1 is 153, X2 is 7, N2 is 128, we're testing not equal to, and boom, I'm going to calculate. So it gives me my test statistic as well as my p-values. It also gives me my p-hats if I want to know those. Okay, so in step 2, my Z test statistic is 0.79. I always round these to 2 decimal places because the critical region is 2 decimal places. So in my step 3, we're going to draw our critical region here. Okay, I go back up here and look at right-tailed, left-tailed, or two-tailed. This is a two-tailed test. So I'm going to have 2 areas of rejection here. Remember, I'm shading my rejection region. Okay? So, oops, I forgot to write down alpha, and 0.1 was my level of significance. It said use a 1% level of significance. So alpha is 0.01. So when I go to my table, these are Z critical values. If you were using T, we have to go to the T table. Two-tailed test. Alpha 0.01 means I'm going to have a plus 2.58 and a minus 2.58. So remember, two-tailed tests, you're always going to have 2. This is negative 2.58. This is positive 2.58. Remember, my middle here is 0. So the question is, where is 0.79 on this graph? Well, it's between 0 and positive 2, correct? So 0.79, I'm going to say somewhere right here. So remember, on the critical region graph, this is my rejection region. Since my test statistic is not in the rejection region, I do not reject H naught. See how all these knots go together? Remember, this means the same thing as fail to reject. So on, I know, WebAssign, it says fail to reject. Make sure you tell me what you're rejecting or not rejecting. You always need to put the H naught there. And it's always H naught, okay? So we do not reject H naught. So let's write down our p-value approach. The p-value method is we reject H naught if p-value is less than alpha. So on my calculator, I had a p-value. I always do this one 4 decimal places, 0.4298. The question is that less than 0.01? Well, clearly no, right? So if the answer is no, we say do not reject H naught. Do not reject H naught, or we could say fail to reject. Okay? Again, the reason I like to say do not reject H naught is when we do this part here, at the 1% level of significance. Remember, in my interpretation, I'm always saying I do or do not have enough evidence to prove the alternative. So in this case, I do not. I cannot prove, I don't have enough statistical evidence to say that they're different. Therefore, I have to assume that they're true. Or I'm sorry, I have to assume that they're equal. I didn't prove that they're equal, but I'm assuming that they are equal because I do not have enough statistical evidence to prove the alternative. So at the 1% level of significance, we do not, because we did not reject, have enough statistical evidence to conclude that, I flip back to my problem, so I lost my page here. The population proportion of high school dropouts on Oahu is different either way from that of Sweetwater County. Okay, so remember in hypothesis testing, even though if we calculate our population proportions is different, there's not enough statistical evidence to say that they're different.